Okay, so we discussed all about the inverse trigonometric functions or these derivatives formulas, no? Okay, so first is the derivative of quantity of sine inverse u is equals to du over square root of 1 minus u squared. Then second is the derivative of cosine inverse u, that is equals to negative du over 1 minus u squared. Then next is the derivative of tan inverse u is equals to du over 1 plus u squared. Then next is the derivative of cotangent inverse u, that is equals to negative du over 1 plus u squared. Okay, so next is the derivative of the quantity of secant inverse u, that is equals to du over u square root of u squared minus 1. Then another is the derivative of quantity of cosecant negative 1 u, that is equals to du over the u square root of u squared minus 1. Okay, so let us consider this example. The number 1 is y is equals to sine inverse quantity of x to the power 4 plus 1. Okay, so in this case, the problem in terms of inverse trigonometric functions, so we can now use this formula, no, which is number 1, okay, to solve the problem given. Okay, so let u here that is equals to x to the power 4 plus 1, then du that is equals to 4x cubed. Okay, so since we have the equivalent derivative formulas, okay, so therefore y prime is equals to, where du is 4x cubed, okay, over the square root of 1 minus x to the power 4 plus 1 then to the power 2. Okay, then okay, so that is the final answer. Okay, so if you given this problem, y is equals to cosine inverse, then we have cosine to x. Okay, use this number 2, no, which is the derivative of cosine inverse u is equals to negative du over square root of 1 minus u squared. Okay, so let u here that is equals to cosine to x. Okay, so the derivative of take note that the derivative of cosine, okay, cosine u that is equals to negative sine u du. Okay, okay, so therefore du here that is equivalent to negative sine to x. Okay, and then we apply chain rule here to derive the to x. Okay, so which is equals to 2. Okay, so therefore du here that is equals to negative 2 sine 2x. Okay, then apply this formula. So therefore y prime here that is equals to which is du here we can write negative according to this formula, no? Then do here negative 2 sine 2x, okay, over we have the square root of 1 minus which is our u, which is cosine 2x, okay. Then we finalize our answer. So this can be positive, so negative times negative, that is positive, so we have 2 sine, okay, 2x, okay, over the square root of 1. Actually we have the squared here, okay, then minus 1, the square root of 1 minus quantity of or cosine squared, okay, cosine squared 2x, okay, okay. So take note that in the trigonometric identities, that in relation to Pythagorean, the cosine squared x plus sine squared x, that is equals to 1, okay. So when you get the equivalent of sine squared, so we have here sine squared x, so that is equals to 1 minus cosine squared x, okay. So we can now the substitute the equivalent of value of sine squared, which is 1 minus cosine squared x again in this case. So in this case we have 2 sine 2x, then we can get the square root of sine squared x, no, sorry, this can be sine squared 2x, okay, something like that, no. The next we simplify. So according we have square here, so we can now cancel the radical and this square root. Okay, so we can now cancel this radical symbol and the squared, and then we obtain this sine 2x, okay, over the sine 2x, okay. Okay, so to finalize the first derivative, that is equals to we can cancel out this, that is equals to 2, okay. So that is the final answer.